Hello everybody, welcome to this video in which we are going to discuss about vectors in one dimension. Okay, let's consider x-axis. We're going to consider the vectors along x-axis. I'm taking right side positive x and left side negative. And vector is a physical quantity which has got both magnitude as well as direction. So a vector is generally represented with a letter, alphabet, with a bar on top. And also geometrically you can represent it as an arrow. You can see that light blue color arrow. That's a geometrical representation of vector. So this is much more convenient for the visualization purpose. So this arrow, direction of the arrow indicates the direction of the vector, and the length of the arrow is proportional to the magnitude of the vector, size of the vector. So say for example, I'll keep it here like this. You can read over here a bar, that put a modulus function, modulus of a bar, or otherwise we call it as magnitude of the vector a bar, is 5 units. And then we have the second term theta. Theta is the angle made by the given vector with the positive x-axis. In coordinate geometry we always measure the angles with respect to positive x-axis. Because it is parallel to positive x-axis, it makes zero angle with positive x-axis. And you have the next one, a suffix x, ax they call it as. It is a component of vector along x-axis, or it is the influence of the vector along the x-axis. And because the vector is along x-axis only, it has got its complete influence along x-axis. So entire 5 units of the vector is directed along x-axis only. And what about ay? It is the influence of vector along y-axis, component of vector along y-axis. Because it doesn't have any orientation in y direction, it has no influence. So vector along x-axis does not have any effect along y-axis. That's the meaning of it. Okay. Anyway, so we have this vector. It can be along positive x. We say it is a positive vector. Alright. Otherwise it can be negative direction. When it is negative direction, magnitude would be positive only because size of the vector can never be negative. But the direction will be 180 degrees now. Alright. 180 degrees in the sense from positive x-axis. With respect to positive x-axis, it has to turn all the way from there to here by making a half circle 180 degrees to reach that negative direction vector. So whether it is a positive vector or negative vector, magnitude would be positive only. But you see ax will be positive when it is a positive vector. It is negative when it is a negative vector. So x component would be positive or negative, but magnitude would always be positive. Okay, that is one thing. Now let us consider another vector b bar. I'll show that b bar also adjacent to it. Let's say we'll take it here. Now you see b bar. B bar has got a magnitude how much? 5 units. A bar has got a magnitude 10 units. So they don't have equal magnitude, but they are having the equal direction. They are in the same direction along positive x-axis. So these two vectors are in the same direction, so we call them as parallel vectors. Two vectors which are in the same direction are called parallel vectors, and the angle between these two parallel vectors is going to be 0. Suppose I turn the vector in opposite direction. Now a bar is along positive x-axis and b bar is along negative x-axis. The angle between these two vectors, you see that it is 180 degrees. From a bar to b bar, if you want to turn, you need to turn by 180 degrees. So these two vectors are called anti-parallel vectors. Otherwise they call it as unlike vectors. So that's another thing. One more thing is, suppose they have equal direction. In addition to that, if they have equal magnitude, I'll indicate the magnitude also there. You see they have equal direction. They also have equal magnitude. In that case, we say that these two vectors are equal. A bar equal to B bar. Both of them are equal vectors. A bar and B bar are equal vectors with respect to each other. What if I turn to the other side? Okay, it has got same magnitude. Let's take same magnitude, but opposite direction. Now they have same magnitude, but they're directed opposite to each other. Such vectors are not called equal vectors. They are called couple vectors. In some books, they also mention them as negative of each other. A bar is a negative vector of B bar. B bar is a negative vector of A bar. A bar is negative vector with respect to B bar. B bar is negative vector with respect to A bar. The way they represent it also, they say A bar equal to minus B bar, B bar equal to minus A bar. That's how they write it. Either couple vectors, otherwise we can call them as negative of each other. Okay, so let's consider two vectors in the same direction. We can find the result of those two vectors, summation of those two vectors. Imagine these two are forces and I keep an object there and these two forces are acting on them, 10 Newton and 50 Newton. Both of them are acting simultaneously on the body in the same direction. Then what is the net force acting on the body? We want to understand that. We call it as a resultant force or sum of the forces. The S bar is a symbol they use. This dark blue color is a resultant of those two vectors A bar and B bar. We write it as S bar equal to A bar plus B bar. And if you look at it, the direction is in the same direction. A bar is along positive x axis, B bar is also same direction, S bar is also along positive x direction. And if you also look at the magnitude, A bar magnitude 10 and B bar has 15 units. When you add them together, 10 plus 15, you are getting 25. So it's pretty simple, straightforward. The magnitude of S bar is the sum of the magnitudes of A bar and B bar. 10 plus 15 equal to 25. Very, very straightforward. But now, if you take the vectors in opposite direction, then it can become very interesting. Let's consider that. Okay, let's say 5 units I consider now. You see, A bar has got a magnitude 5 units, B bar has got a magnitude 15 units, but S bar doesn't have the magnitude 15 plus 5, 20. Rather, it is having 10. So that's interesting because here it looks like a subtraction. Even though we call it as a resultant of those two, vectorial addition, vectors are added, but the magnitudes are subtracted here. That's because they're opposing each other. We say that two forces are opposite each other, they try to oppose each other. Okay, they are not supporting each other. Parallel vectors support each other and anti-parallel vectors oppose each other. So you see that when vectors are opposite to each other, the resultant will have the magnitude which is the difference of the two magnitudes. So and which is going to determine the direction of the vector. You see between A bar and B bar is bigger vector. So the bigger vector decides the direction. Bigger vector is along positive x-axis, so the resultant S bar would also be along positive x-axis. What if I make A bar bigger? Let's say I'll make it some 18 units. Now you see A bar is bigger. The magnitude is 18 minus 15, 3, and the direction is directed in the negative x direction because A bar is bigger vector which is along negative x direction. So that's pretty easy to understand that. So the direction of the resultant is determined by the direction of the bigger vector. And the magnitude would be the difference of the two magnitudes when they are opposing each other. So it's very easy to understand these forces when they are acting in opposite direction in terms of the forces. Okay, I'm taking forces as an example for this vector addition. That doesn't mean that we should consider only forces. Any vector will obey the law, but taking forces will give you that intuitive feel why it should happen like that. Okay, the next thing is, see these vectors I'm able to move around. Freely I can move around. Alright, I can move these vectors. So the idea is that even if I move these vectors anywhere in the plane, their effect is not changing. So those vectors which can be moved around and yet there is no change in effect of them, such vectors are called free vectors. So these vectors are free vectors. Of course, you will be coming across sometimes where the forces cannot be changed anywhere you feel like. If you apply at different points, you will have different effects of it. In such situations, that vector is called polar vector. Polar vector is the one which cannot be moved around. Its point of application is very important for us. Free vectors are the ones which can be moved around without changing direction and magnitude, and yet they have the same influence. That's another definition you have it. Okay, now we have taken two vectors. What about having three vectors? You can also have three vectors added. Let's take one more vector C bar. So I can have two vectors in positive direction and one vector in negative x direction. You see B bar and C bar, they are parallel vectors, but B bar and A bar are anti-parallel vectors. Angle between B bar and C bar is 0, but angle between A bar and C bar is 180 degrees. Now I want to find the resultant of all these three vectors, A bar plus B bar plus C bar. It's a vectorial addition. But when you go to the magnitude, you see that 15 and 16 are in the same direction. They are supporting each other. 15 plus 16, 31. But 18 is opposing it. So you need to subtract that 18 to get the resultant. 31 minus 18 is 13. So the magnitudes they are not added up. If they are in the same direction, they are added up. If they are in opposite direction, they are subtracted. But we say it's a vector addition. It's a bar plus b bar plus c bar. Resultant of those three vectors is s bar, and it has got a magnitude 13 units along positive x-axis. So likewise, we can have 3 vectors, 4 vectors, any number of vectors can be added like that. That's another point. Okay, let's put the C bar back. Now, I want to see how can we do the subtraction of vectors, vector subtraction. So this is interesting actually. How do you subtract two vectors? A bar plus B bar, okay, we have got it already, understood. How do we find A bar minus B bar? So in mathematics, there is no separate definition for A bar minus B bar. We use the idea that subtracting is equivalent to adding a negative quantity. So they say A bar plus B bar is equal, A bar minus B bar is equivalent to A bar plus minus B bar. So you take a couple vector to B bar, you take a couple vector to B bar, couple vector meaning what? It should be in opposite direction. And it should have the same magnitude. So you see that B bar and C bar are couple of each other. They are equal in magnitude and opposite direction. Let's say I want to find A bar minus B bar. So minus B bar is nothing but C bar. Alright. So you just add C bar to A bar, you get A bar minus B bar. You take out B bar from here, remove it. You add these two. A bar plus C bar is equal to A bar plus minus B bar, which is A bar minus B bar. That's how they do the subtraction part of it. That's pretty easy. So subtraction, there is no separate rule to it. Subtraction is taken as the addition of negative vector or addition of couple vector. You can take it that way. Okay, that's what we have understood here in x direction. Same way you can go to y axis also. So let's consider y direction, and same way you can go for z axis as well. Consider y axis. So let's say we have a vector d bar. Okay, it is along positive y axis. If you click on it, you see that magnitude is 5 units and the angle is 90 degrees. You see, with positive x-axis, it has to turn anti-clockwise or counterclockwise by 90 degrees to get to this vector d bar. So counterclockwise direction is taken to be positive. And you see dx is 0. It has no influence along x-axis because it is directed along y-axis. It is completely oriented along y-axis, so dy equal to plus 5. Plus 5 because it is along positive y-axis. So if I turn this vector down, you see now this angle has become minus 90. What does it mean? With respect to positive x-axis, you have to turn clockwise to reach that second vector, that vector here. So clockwise rotation is taken to be negative angle. With respect to positive x-axis, if you turn anti-clockwise, that's taken to be positive angle. Clockwise is taken to be negative angle. That's why it is minus 90 degrees. And again, dx is 0 because it has no influence along x-axis. dy is minus 10 because it is directed along y. But the magnitude is 10 only. Remember, magnitude can never be negative. It's just the size of the vector we are talking about. The component of the vector along y-axis is negative because it's along negative y direction. That we can understand. So same way we can take another vector e bar. Okay, you can add these two vectors and find the resultant. So e bar is along positive x-axis, positive y-axis, and d bar is along negative y-axis. Resultance is going to be d bar plus e bar will be what s bar equal to. It's not the addition 10 plus 12, but it is going to be 12 minus 10 because they are opposite to each other. That's going to be 2 units, and the bigger vector is e bar, which is along positive y-axis. So the resultant would be in the direction of bigger vector. You can increase it, you see it is going to increase. Okay, if you decreased, you see that it is going to decrease, and it will be in the direction of d bar because d bar is a bigger vector now. So the same rules apply. So that's about this vector addition in one dimension. With that, I'll close here. Until next time, goodbye. Thank you.